Assalamualaikum. How are you, Shavir? Assalamualaikum. How are you, Shavir? Hope you're doing well and everything is fine over there.
Yeah, I'm good.
Okay, are you ready for today's lecture?
Yeah,
Hope you revised your previous lectures, what we did in our last lecture. Have you go through those
yeah,
lectures? Do you have any question related to those lectures?
no,
Okay, okay, that's good. Okay, so let's start our today's lecture. Let me share my screen with you.
uh,
So my screen is sharing with you, right?
yeah,
Okay. So today's our lecture number 13, and in today's lecture, basically we will discuss about gases law and pressure. We already discussed in previous lecture about pressure in different states, like pressure exerts by solid, pressure exerts by liquid, and pressure exerts by gases. In today's lecture, basically we will discuss in more detail about the pressure in gases, and this is also known as gas law. Okay, so our learning objectives are basically we will first understand the gas pressure in terms of molecular motion, and then we will study the relationship between pressure, volume, and temperature. What is the relationship between these factors, pressure, volume, and temperature? We will discuss in today's lecture in detail. Then we will move on towards an important laws in physics, which is known as Boyle's law and pressure temperature law. Okay, and then we will solve some then we will solve some numerical problems based on our gases law and pressure topic, and last we will move on towards real life examples of gas law. So let's start our first topic, which is about gas pressure and molecular theory. What is molecular theory? You know that everything in the universe are made up of tiny particles, and those particles are known as atoms. And for whereas gas is concerned, gas is also made up of small atoms, molecules. Okay, so gas pressure is basically caused by the collision of gas molecules. And definitely, you know that the molecules of gas must be enclosed in some closed container. So we have to close our gas into some closed container, and the molecules of that gas exerts pressure on the walls of the container. This is known as gas pressure. How it depends? The higher the temperature, you do that, the higher the temperature it increase, the more the kinetic energy of the molecules. If the kinetic energy is increased by increasing the temperature of the gas, what would happen? Now the molecules of the gas now forcefully collides with the walls of the container, and if they collides more, it means they will exert high pressure. So what we know that by increasing the temperature, the kinetic energy of the particles got increased, and when the kinetic energy increased, those atoms will collide with the walls of container more forcefully, and they exert more pressure. So more temperature, more pressure. All right.
mm,
Hmm. So we see here there is a direct relation between temperature and pressure. Another thing is that by decreasing the volume, what does volume means? If we decrease the
volume,
volume, it means we are reducing the quantity or increasing the quantity.
uh, nutrition,
Yes, reducing the quantity. So if you reduce the quantity of the particles, means if you are taking a less number of particles, or you can say if you are taking less gas. So by reducing the volume of a gas, what would happen? Now your particles have less space to move. Okay, reducing volume means decreasing volume means you reduce this the space. So if you reduce this space, now again those particles of the gas collide more forcefully. And if they collide more forcefully, it means you increase the and they exert the pressure more. So there are two factors how you can increase the pressure of a gas. The first thing is by increasing the temperature, you can directly increase the pressure. The second thing is that how you can increase the pressure of a gas by decreasing the volume. It means by reducing the space. If you reduce the space, those particles of atom collide more forcefully with the wall of container and thus the pressure got increased. So these are basically the two main points. Understood?
Mm-hmm.
Yes. So you can use to explain behavior of gases in balloons, tire and spray cans. These are some examples of this. Okay.
Yeah.
Now move on towards our important law, which is known as Boyle's law. We understood these two factors. Now, based upon these two factors, there are important laws. The first law is called as the Boyle's law. Boyle's law basically tells us about the information, the relationship between pressure and volume. Okay, Boyle's law tells us basically the relationship between pressure and volume. What Boyle's law states? Boyle's law states that for a fixed mass of a gas, okay, so you must have to take a fixed mass, means mass do not vary. And another thing you have to take temperature as constant. Okay, what would happen? The
Yeah.
pressure of a gas is inversely proportional to the volume. So Boyle's law states that for a fixed mass of gas and at constant temperature, your pressure of a gas is inversely proportional to the volume. What it means? It means that if the volume of a gas is decreased, the pressure is increased. Why? Because there is an inverse relation between pressure and volume. Okay. So if you decrease the volume, so pressure would increase. And if you increase the volume, the pressure decrease. Why? Because according to Boyle's law, we know that pressure is inversely proportional to volume. If you increase one thing, the other thing should decrease. All right.
Mm.
How you can write this
Okay.
mathematically? You can see here pressure is inversely proportional to 1 by V, which is the volume. Okay. P stands for pressure, and this is our directly proportional sign 1 by V. So it means pressure is inversely proportional to volume. And if you want to move this volume to the other side, what you have to do, you have to multiply this on both sides. When you multiply on this side, V cancels with V, and when you multiply V on this side, so it becomes PV, PV. And you know that in
Mm-hmm.
mathematics or physics, whenever we remove the directly proportional sign, there is an equal sign introduced with a constant. Do you know this concept?
I'm
Whenever
pretty sure I've heard of it.
whenever we have to open the directly proportional sign, you must have to introduce an equals to sign with a constant. Okay?
Oh,
Yes.
yeah.
Here P is inversely proportional to 1 by VV and it becomes PV equals to constant. Now let's rearrange our formula. Let suppose if you increase the pressure, so volume is decreased. So your new formula would becomes P1 V1 equals to P2 V2, whereas P1 V1 are the initial pressure and volume, and P2 V2 are the final pressure and volume. Understood? Keep
Yeah.
remember this formula. We have to use this formula in numericals. All right. Hmm.
Mm-hmm.
Next, the condition we already understand in the definition of the Boyle's law that you must have to uh, uh, remain a fixed amount of gas. Okay, amount of gas, or you can say the mass of a gas, you must have to take constant. Okay, another thing is you also have to take temperature as constant. How we can see the graphical representation? For the
Mm.
graphical representation of the Boyle's law, you have to take pressure on y-axis and you have to take volume on x-axis. And once you draw the graphical representation of pressure and volume, or you can see the Boyle's law graphical representation, you will see a curve, hyperbolic curve. Here you can see on x-axis we are taking volume, and on x-axis we are taking volume, and on y-axis we are taking pressure. And we know there is an inverse relation between pressure and volume according to Boyle's law. You can see as we are increasing the volume, the pressure is decreased.
Yeah.
But if you decrease the volume,
Oh.
so you can see there is a large amount of pressure. All right. So this hyperbolic curve
Yeah.
you can make if you draw a graph between pressure and volume. This graph is important, and this is graph for which illustrate the Boyle's law. Okay. Uh, Now, real life application
Mm.
is syringe. You know, syringe. What we have to do with this syringe, whenever
Mhm.
when the plunger is pulled, means if you push back this syringe pump, so the volume increases in this syringe pump. Volume increases means the space between the syringe increases. And if the volume increases, according to Boyle's law, the pressure must decreased or increased?
Decrease.
Yes, decreased. So whenever you increase the volume in a syringe, the pressure drops. And when the pressure drops, so easily the fluid which you want to suck comes into the syringe. So this is a practical application. The next practical application is scuba diving. You know, scuba divers have to go deeper inside. Okay, and as you go deep into the sea,
Mhm.
you know that the pressure increases. As you go more deeper, the pressure
Mhm.
increases. And at the depth of the sea, the pressure is more. So if the pressure is increased, according to Boyle's law, the
Mm.
volume must be,
Uh, decreased.
yes, the volume must be decreased. That's why whenever the scuba divers go without any instruments, if they go more deeper into the sea, the volume decreased in their lungs, okay, which is very harmful. That's why
Mhm.
scuba divers must go with proper instruments. All right.
Yeah.
Yes. Is there any question?
No.
Okay.
No.
So here is graphical representation you already see between pressure and volume. Now move on towards
Mhm.
worked examples of Boyle's law. A gas has a pressure of 100 kilopascal and volume is 3 liters. It is compressed to 2 liters. Find the new pressure. So you have initial pressure is given, and you know initial pressure is denoted by P1. Okay, so P1 is
Mhm.
100 kilopascal, and also the initial volume is given, which is 3. So you know the formula of Boyle's law. What is that? P1 V1 equals to P2 V2. Okay,
Yeah.
when you compress this gas, the new volume is given, and this is the final volume, and you know the final volume is denoted by V2. It means this 2 liters is the value of V2, and what you have to find the final pressure. new pressure. And you know, new pressure or final pressure is what? V P2. All right, it means you have to find
Yeah.
P2. If you want to find P2,
B2.
you have to move this V2 to the other side. So just putting the values, P1 value is 100, so 100 multiplied by V1, V1 value is 3, multiplies by 3 equals to P2, which you have to find, multiply by V2. V2 is 2. You have to find
Mm-hmm.
P2, move this 2 to the other side. Divide this 2 to the other side. 100 multiplies by 3 becomes 300. 300 divided by 2, it becomes 150. And because initial pressure is in kilopascal, so final pressure is also in kilopascal, because you know what's the unit of pressure? It's pascal, right?
Yeah.
Again, next problem similar. P1 is given, which is 250 kilopascal. Initial volume is given, which is 4 liters. Again, final volume is given, which is 5 liters. You have to find the final pressure. You know what's the formula? P1 V1 equals to P2 V2. If you want to find P2, you have to divide this V2 to the other side. Now your formula becomes P1 V1 divided by V2. Just put the values, which is all given, 250 multiplies by 4 divided by V2, which is 5. You will get your answer, which is 200 kilopascal. All right.
Mm-hmm.
Hmm.
Yeah.
The next example is a gas is compressed from 6 liters to 2 liters. Can you tell me this is volumes? Which is initial volume? 6 liter is initial or 2 liter is initial?
Uh, 6.
Yes, 6, because here is mentioned from. So a gas is compressed from. So from means this is your initial volume. To it means it is your final volume. And initial pressure is given, which is 120 kilopascal. You have to find the final pressure. It means you have to find the P2. Again, you have to use the simpler formula P1 V1 equals to P2 V2. And if you want to find P2, you have to move this V2 to the other side. So 120 multiplied by 6 becomes 720. And when this 2 goes to the other side, so 720 divided by 2, it becomes 360. Your initial pressure in kilopascals. That's why your final pressure is also in kilopascal. Okay,
Mhm.
right.
Yeah.
Now let's move on our second law, which is known as Gay-Lussac law. Okay, and Gay-Lussac law basically tells us about the relationship between pressure and temperature. You know, Boyle's law tells us the relationship between pressure and volume, but
Mm-hmm.
Gay-Lussac's law tells us the relationship between pressure and temperature. According to Gay-Lussac's law, what it says, it describes the relationship between pressure and temperature. But what are the conditions? The conditions are, again, you have to take a fixed amount of gas. Means the mass remains same. You don't have to change the mass of a gas. And the next important thing is you also have to take the volume now constant. By taking volume and amount of gas constant, Gay-Lussac's law tells us that pressure of a gas is directly proportional to the temperature. Okay,
Mm-hmm.
so if there is a direct relation between pressure and temperature, can you tell me if we increase the pressure, what happens to the temperature?
Uh, it remains constant.
Um, According to Gay-Lussac's law, your pressure is directly proportional to temperature. And you know that whenever two quantities have a direct relation, if one is increased, the other is also increased. And if one is decreased, the other is also decreased. This is the this is known as direct relation. Okay.
Mm.
So according to Gay-Lussac's law, It tells that pressure is directly proportional to temperature. So can you tell me, by increasing the pressure, what happens to the temperature?
It also increases.
Wonderful. And if you decrease the pressure, what happens to the temperature?
It also decreases.
Yes, also decreases. So this is known as Gay-Lussac's law, which tells us about the direct relationship between pressure and volume. But what the important things you must have to take, amount of gas means the mass, and the volume you have to take constant. Same thing, at constant volume or at constant mass, the pressure of a gas is directly proportional to the temperature. And you have to take temperature in kelvins. Can you tell me how many units of temperature are there?
Um,
No.
two, three.
Yes, three. Can you name them?
Uh, Celsius, Fahrenheit, and Kelvin.
Yes, good. You are right. So these are the three units of temperature. But in this Gay-Lussac's law, whenever you are dealing with the calculations, you must have to convert your temperature into kelvins. Okay. So according to Gay-Lussac's law, we know that pressure is directly proportional to temperature. So it means, as you tell me, that if the temperature of a gas increase, the pressure also increases, and vice versa. Vice versa means if you decrease the pressure, the temperature also decreases. Okay, but the important thing is that you have to take the volume remains constant. So here you can write mathematically the relationship between pressure and temperature, because there is a direct relation between pressure and temperature. How you can write it mathematically is that P is directly proportional to temperature. But in Boyle's law, you know that your pressure is inversely proportional to volume. That's why you have to write it as 1 by V. 1 by means inverse relation. But in Gay-Lussac's law, there is a direct relation. That's why you have to take P is directly proportional to T. All right.
Mhm.
And
Yeah.
as I told you, whenever you have to move thing to the other side, you have to divide. So you have to divide T on both sides. P divided by T and T divided by T. T divided by T cancels, and you will only left with P divided by T. And as I mentioned you before, whenever you have to remove the directly proportional sign, you must have to introduce an equals to sign with a constant, right?
Mm.
So same
Yeah.
thing you did here. So it becomes P divided by T equals to constant. By rearranging the
Mhm.
formula for initial and final, how you can write now P1 divided by T1 equals to P2 divided by T2, whereas P1 and T1 are the initial pressure and temperature, and P2, T2 are basically the final pressure and temperature, right?
Mhm.
Again, keep remember this formula. We have to use this formula now in our problems, right?
Yeah.
Perfect. Important note is same thing which I mentioned you before. You must have to take your temperature in kelvins. And whenever, if your temperature is mentioned in Celsius, you know what's the conversion, how we can convert Celsius to Kelvin. If your temperature is in Celsius and you want to convert it into kelvins, what you have to do, you just have to add your Celsius temperature with 273. This is the formula. Kelvins equals to Celsius plus 273. If your temperature is in Celsius, just add 273. You successfully convert it into kelvins, right?
Mhm.
Okay, so now let's see the graphical representation of Gay-Lussac's law. Because Gay-Lussac's law tells us in a relationship between pressure and temperature, so now you have to graph between pressure and temperature. And you have to take pressure on y-axis. This is your y-axis, am I right?
Mhm.
And this is your x-axis. You have to take temperature in kelvins and on x-axis. And according to Gay-Lussac's law, we know pressure is directly proportional to temperature. Whenever you draw a graph of direct relation, the graph is always straight line, right?
Yeah.
Because the concept, you know, that by increasing the temperature, pressure also increases. And by decreasing the temperature, pressure also decreases. So there is a direct relation, and whenever you are draw a direct relation graph, the graph always would be straight line.
Yeah.
But here in Boyle's law, there is not direct relation. There is an inverse relation between pressure and volume. If one thing increases, the other decreases. If this decreases, the other increases. This is meant by inverse relation. That's why the graph is hyperbolic. Okay?
Mm.
But whenever you draw a graph of a direct relation things like pressure and temperature, you can see the graph would be straight line.
Mm.
Any question regarding Gay-Lussac's law?
Huh.
Okay. Now again move towards our real life examples. The first one is the pressure cooker. What is
Mm.
meant by this? Because you know we have to cook some things, and some things must be cooked at some high temperature. So as the temperature increases inside, so does the pressure also increases. Because according to Gay-Lussac's law, the pressure is directly proportional to the temperature. We must have to increase the pressure inside the cooker. That's why we need a high temperature. So by giving high temperature, you can easily increases the pressure of inside the cooker. Okay.
Mm.
And the second example is spray cans. Okay.
Mm.
By heating a sealed can, you can increases the pressure inside. Let's suppose you have a soda can, and if you increase the temperature of that soda can, there is a chances that your can cause it to burst. Why? Because when you give a temperature to the can, the pressure of a can also increases, and pressure goes its maximum value and it causes the can to burst. Okay, so there is a direct relation between pressure and temperature.
Mm.
The next thing is tire pressure. You know that we insert pressure in our tires of cycles or motorcycles or cars on hot summer day.
Mhm.
If the pressure of a gas is more inside your tires, there is chances that your tire would burst. Why? Because in hot summer day the temperature is very high. And if the temperature is very high, the pressure inside the tire should also be very high because there is a direct relation between temperature and pressure. That's why there are chances in hot summer day. If you fully fill your tire, there are chances that your tire may burst. That's why in hot summer day you must have to insert less gas, and in cold days, winter days, you have to insert gas more. Okay.
Mm. Yeah.
Now move on towards our worked examples of Gay-Lussac's law. Your pressure, initial pressure is given, which is 200 kilopascals. Initial temperature is given, which is 300 Kelvin. Your final temperature is also given, which is 400 Kelvin. They are asking you to find P2. So
Mhm.
can you tell me what is the formula of Gay-Lussac's law?
P1, P2, no, P1, T1, uh, equals or over P2, T2.
Yes, you are right. This is the formula P1 divided by V1 equals to P1 over P2. P1 divided by T1 equals to P2 divided by T2. This is your Gay-Lussac's law formula. P1 and P1 is given. You have to find P2. Right? You have to
Mm.
find P2. If you want to
Yeah.
find P2, the T2 is extra. You have to multiply this T2 to the other side. So your formula becomes P1 multiplied by T2 divided by P1. All right, just you have to rearrange the formula for P2, right?
Yeah.
Hmm.
Uh-huh.
Now you just have to put the values of P1, T2, and T1. P1 is 200 and T2 is 400 divided by T1, which is 300. Just substitute, you will get your answer. Your answer should be 266.7. If your initial pressure is in kilopascal, so your final pressure is also in kilopascal, right?
Mm-hmm.
Okay. And last numerical, a gas has pressure 100 kilopascal. So can you tell me this is P1 or this is P2?
Uh, P1.
Yes, this is P1. And the temperature is 27 degrees Celsius. You have to find pressure. It means you have to find the final pressure because P1 is given, so definitely this should be P2. So you have to find again P2. If this is initial pressure, so this temperature should be T1 or T2?
P1. T1.
Oh, T1, yes. And this is
T2.
T2. But can you tell me temperature is in Celsius or Kelvin?
Uh, Kelvin.
In question, can you tell
Oh,
me
Celsius.
Celsius? So what you can do with this? According to Gay-Lussac's law, you must have to convert your Celsius value into kelvins. How you can convert 27 Celsius into Kelvin?
I don't know.
Okay, so here we see how you can convert your Celsius to Kelvin. As I mentioned you before, you just have to add 273 with the value. Okay,
Oh, yeah.
so if the value is 27, add 27 with 273. What should be your answer?
Um, 250 Kelvin. 250 Kelvin.
273 plus 27. I think it should be 300.
Oh, yeah.
Okay.
300.
And now it is 127. If you want to convert it into kelvins, you have to add with 273. So 273 plus 127. What should be your answer?
Um, is it 400?
Yes, this is 400. So you can see this is our T1, which is 300, and this is our T2, which is 400 Kelvin. Now, okay.
Mm-hmm.
And now you have to find final pressure P2. Again, you know what's the formula. Formula should be same. P1 divided by T1 equals to P2 divided by T2. And if you want to find P2, you have to move this T2 to the other side. So formula becomes P1 multiplied by T2 divided by T1. So P1 value is 100 multiplied by T2.
Mm-hmm.
T2 value is 400 divided by T1. T1 value is 300. Now you just have to substitute. You will get your answer, which is 133. If your initial pressure is in kilopascal, your final pressure is also in kilopascals. Now, right?
Yeah.
Any question regarding these problems?
No.
Okay. Now move on towards key points which you have to remember. Again, things you know that always you have to convert Celsius to
Kelvin.
Kelvin before calculations. Okay. And you have to use the correct formula based on volume or temperature is held constant. You know, there are two laws. One law is known as Boyle's law, which tells us the relationship between pressure and volume. Okay,
Mm-hmm.
pressure and volume. And the second law is known as Gay-Lussac's law, which tells us about the pressure and temperature. So according to these values, you can easily understand which concept you have to apply, which formula you have to apply. And the last, there is a quick quiz for you. So can you tell me what happens to the pressure when the volume is increased?
Um, Uh,
If, if
decreases.
yes, decreases, because you know that according to Boyle's law, pressure and volume are inversely proportional to each other, right?
Yeah,
So if volume is increases, so definitely pressure decreases. Okay. So
yeah.
can you convert 0 degrees Celsius to Kelvin?
Uh, 273 Kelvin.
Yes, because 0 plus 273, answer is again 273. Okay.
Yeah. Mm-hmm.
So 0 Celsius is equal to 273 kelvins.
Yeah.
Last, a gas at 180 m. ATM stands for, ATM is the unit of
Um,
pressure. Okay.
yeah.
Okay. So if a gas is 1 atm, occupies 2 liters. 2 liters means it is volume or temperature?
Volume.
Yes, volume. So initial pressure is given, means P1 is given, and initial volume is given, V1 is given. And again, what volume? It means you have to find final volume. It means you have to find V2. And again, P2 is given, which is 280 m atmospheric pressure. Okay.
Yeah.
ATM stands for atmospheric pressure. Okay.
Yeah.
So how you can calculate?
Um, what is it? The
What is,
P1,
yes, what's the formula?
P1V, the P1 B1 uh equals to P2 V2.
Oh, yes, you're right. P1 V1 equals to P2 V2, right? And if you want to find V2, you just have to divide this P2
Yeah.
to the other side by just putting the values of P1 and V1 and P2, which is 1 multiplied by 2 divided by 2, you will get your answer of V2. And if your initial volume is in liters, so your final volume is
Yeah.
also in liters.
Yeah.
Okay.
Mm-hmm.
Okay, now these are some assessment questions for you. 5 questions which you can do practice at your homes for your better understanding for regarding today's lecture.
Yeah.
Okay, so any question regarding today's lecture?
No.
Okay, so
Right. Thanks.
okay, thanks for
Bye.
watching. Allah Hafiz.
Bye. Bye. Bye.